True or false? In number 1 we got a single vector by itself is linearly dependent. Is false. In fact, if we have a vector, the 0 by itself, in fact this is linearly dependent, except this is a false. A single vector is linearly independent unless that single vector is 0 vector. Number 2, if H is span of B1 through BP, then that's a basis for H. For basis we have to have two things. This collection should span, and that collection is linearly independent. So here we got only the first part, spanning part. It does not tell us whether this collection is linearly independent, so that's false. This is false because we need more information. We need this collection linearly independent. Number 3, the columns of an invertible n by n matrix form a basis for Rn. That's true, because when we have an n by n invertible, that means these columns are linearly independent. In fact, the rows are also linearly independent. Okay, so they form a basis for Rn. That's true. A basis is spanning set that is as large as possible. Now basis means spanning set and linearly independent, two things. To be a basis we have to have two things. The collection, the sets should span the vector space and they should be linearly independent. So as large as possible means when we add more elements it will be still spanning set, but it will be linearly dependent. So this is false. We cannot have more than certain number of vectors. In fact, our basis is a spanning set that is as small as possible. Okay, this should be as small as possible to get linearly independency. Number 5, if a finite set S of non-zero vectors spans a vector space V, okay, so we got spanning set, then some subset of S is a basis for V. So for basis we need two things, spanning set and linearly independent. So it's already spanning. Okay, we have already spanning set. Then if the collection, whatever we have, if this collection is linearly independent, then this is a basis. But if it is linearly dependent, then we can cross out couple of terms and it still spans, and this will be linearly independent. So this is true. The subset, yes, true. And there is a theorem for this. A basis is a linearly independent set that is as large as possible. So basis, again same thing, spanning and linearly independent. So that part is fine. And as large as possible, yeah, that's true, because when we have as large as possible means for the spanning part we can have a lot of members, it doesn't matter, but it's already linearly independent, so it cannot have unnecessary elements. So this is true.